Bonjour everyone, bienvenue dans les streams. I don't know how to say that. Anyway, why are you just staring at me? You're blocking the fan, Jester. What's up? Alright, I'm just gonna put your substitute up on screen. Oh, here he is. Oh, hold on. It is Italian. My name is Italian. As am I. But I live in Spain and I speak French for fun. French is fun, right? Such a fun number to say in French. This is how you say the number 99 in French. I get it right? Yes. That's how you say the number 99 in French. You gotta do arithmetic. You gotta do a little bit of a solve for x type of thing. What's up? Okay, there's Thunder, so he is a little bit scared. So, alright, hold on. Okay, don't... Hold on. Hold on. Come. Ow, 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 ow. Those claws of yours. Quad 20 and 10-9. Yes. Isn't it? Am I wrong? Am I wrong about this? Is this not how you say 99? You don't want to see how you say 100. It's just 100. 99? Oh, well, you Belgians are much smarter. No offense to the French. Well, they're doing more math on their day-to-day life, I guess. So, I don't know. You guys are just wiser. Maybe they are smarter because they practice math more, but you guys are wiser. This guy's scared of thunder. Can you imagine that? Scared of thunder. This guy is angry. You're like an ancient Greek person. Scared of thunder. Scared of Zeus. What's up with that? The worst part is there was thunder earlier, but not now. Now it's raining, to be fair. But, yeah. Anyway. He's gonna be a lapdog today, so you won't see him much. He'll be there. 40 Interesting. By the way, not working on a new project. No. Everything I'm doing still has to do with the operating system. Just sounds really weird to say I'm making regular expressions for operating system development, so I kept that part out of the title. But it is what I'm doing. By the way, if you're in YouTube, there's a link. I highly suggest you click that link and you watch on Twitch, because YouTube is up to some fucking bullshit. And I have to manually monetize all of my streams because they are ignoring my default setting, which is to have the monetization on. And that means that if I forget to do that, or if I'm in a hurry, I don't get any money for the entirety of the stream. 4 hours I wasted on Friday getting no money whatsoever. And there's not much I can do about it. I tried talking to support. It's just an AI. And the AI is just like, well, you need to follow these steps to enable automatic monetization of your streams. And I'm like, I did. It's a bug. It doesn't work. Well, you need to follow these steps to enable the monetization. What is the point of an LLM as a chatbot in support replacing human beings that you fired that no longer work for your company, and then it doesn't do the job? Not only does it not do it better than the human, it does not do it at all. it doesn't do the job. People don't talk to support. I mean, maybe some do, sure. But people don't usually talk to support to get answers for how to do something in a straightforward way. They talk to support when something doesn't work. So the answer is to troubleshoot the thing, not to just tell me, oh, have you tried doing the exact same thing we've told you 10 times already? Yes? Try it an 11th time. The human support team, sure, they would maybe say the same thing, but it's different. Even then, it would be like, okay, we really can't do much about it. We can investigate it, but like, I don't know, it's one of a million bugs that we have. We cannot overstate how much we've been vibe coding. Jester, are you comfortable there? You're about to fall off. Alright, hold on. Let me fix this dude. YouTube disabled monetization on my stream. Not that they demonetized my streams. No, I can easily enable it. It is enabled right now. And I don't have any copyright strikes or any guideline strikes or anything like that. Nothing bad happened. Just that by default, there's a setting that enables monetization by default or not. Because you can choose whether you want to monetize something or not. I have it on by default. It's been, when I start the stream, disables itself. I have to manually go and enable it. On Friday, I didn't think to go and check the setting that is on by default, so I didn't realize until yesterday that my stream wasn't monetized. And I didn't really waste 4 hours. I'm also not doing this for the money. But like, if I was, I lost 4 hours of work. I worked for 4 hours for free. And also, this is the graph for the stream. This is where the stream ends. This is where the stream gets monetized. Because I actually realized and turned on the monetization. It gained like twice as many views as it had before I turned on monetization. It was very much plateau. It was doing good while I was live. Then, nobody was watching the VOD. No comments. Zero. Not even the guy that's like, by the way, thank you for your work. The guy that's like, stream starts at 5 minutes. Thank you for what you do for our community and for the internet as a whole. You are one of the unsung heroes of the internet, and we appreciate you. But yeah, not even that comment. Then I turn on monetization, suddenly people are interested in watching the video and commenting. Isn't that so fucking interesting? Mind you, I could have had monetization on since this moment, but they chose to disable it for no goddamn reason. And the AI is beyond unhelpful. Because it doesn't even say, I'm sorry that happened. It straight up does not understand that I'm telling it there's a bug. It doesn't even comprehend that there's a bug that I'm talking about. It just thinks that I don't know how to enable monetization. Bro. Come on. I had Epic Games support do it once. Told me to reinstall my graphics driver after I told him about the issue in much detail. What I'd done on my PC and how it wasn't fixed. Then I told him it was an account issue because the issue happened only on my account on every device I had the game on. That's real support? Yeah, they're not always super helpful, but sometimes they try. Sometimes they're just not allowed to do things. Like, for example, if I had gone to a real person and been like, hey, I lost this much revenue because you guys disabled monetization on my stream, that would have been, you know, ridiculous. Because, like, how do we know how many people would have watched? We know how many people watched, but, like, maybe people would have donated, maybe they wouldn't have. We don't know. We can't work on hypotheticals. So, that would have been unreasonable. Or even if you could calculate it, maybe it's against company policy. But at least somebody that actually like gives me an answer, even if it's not the answer I'm looking for, is much better than a robot that literally does not understand that I'm reporting a problem to support. It's its entire job, and it does not understand how to do its entire job. Brother. Fucking wasting water, electricity, pirating books and movies and shit for this. Come on. Fuck right off with your AI bullshit. Jester, okay, listen. No. You're digging your claws into me. I'm wearing shorts. Okay? Cannot do this. You cannot do this to me. It's fine. The thunder is gone. Zeus is no longer angry at us. Okay, they're black shorts too. Now they're covered in white hair. You're cute though. Come on, get on the bed. People need to see the sleeping dog. It's very much just the only kind of decoration I had in that corner. I never know what to put there. So the only kind of decoration on this side of the screen is him. So yeah. I found it was a config file in some random folder. I told him to make a note. Reasonable. That's very reasonable. And a human support team wasn't able to help you, but eventually you figured out the issue. They might be able to help someone else. Or maybe it's against policy. Whatever. Policy can be stupid sometimes. You can try. Oh well. On some Reddit post. Nice. Yeah, Reddit is the best support out there, honestly. LLMs are completely useless. Support teams have been fired. All we have is Reddit. Stack Overflow is dead. It's just Reddit now. Okay, Jester, you need to move. No, you need to move. Okay. Yeah, is the deal. Yesterday I worked on my terminal a little bit. It was enjoyable. One less C++ class in the world is always a good thing. By the way, I was having some issues with moving the cursor, so that was a little bit annoying. There's still one bug that I found, and I need to check it out a little bit more. But why was OBS lagging? Why are you lagging? The fuck? But yeah, the terminal. Oh, by the way, I sped up the cursor to 100 milliseconds. That's kind of ridiculous. Let's do half a second. Alright, that's better. The cursor is still ugly, but I'll have to fix that eventually. I don't know. Anyway, I can move it properly now. And it kind of works to replace right now instead of appending, which in normal terminal it doesn't work like that. But again, whatever. That's not even a visual issue, that's just the way that I implemented the thing. I can fix it in post. However, I was talking yesterday about, you know, the systems documentation and whatnot. And a while ago I created a basic documentation system. Let's see, does it even work anymore? I kind of did break it a little bit. No, UI isn't going to work with terminal. That doesn't work. But, is it manual overview? No, okay. I broke it a little bit. But anyway, you're supposed to be able to use the manual by telling it to, you know, the topic that you want to get information on and subtopic, kind of. So I want to get an overview of how the system's terminal works. Which is ironic because you need to do it from the terminal itself, but whatever. The point is there's this page, terminal.md, and there's a section called Overview. I want it to give me that. But I want the overview to actually be, to work somewhat like a summarizer, but manual summarizer, where the way that you write the documentation allows you to do this thing where you like look for subtopics just by annotating them. So this is an example of that. This is the UI page for the, not for the terminal, for the manual. This is the manual page for the UI, and this thing here is supposed to be part of the overview. This is not. This is not. So on. I still wonder if there is an overview section for it to show you that. But then on top of that, get an overview from the window in a desktop, because that's a feature. We talk a lot about it, but these parts are part of the overview. This is not important to the overview. This is more in depth. All the stuff for developers is not part of the overview. Right, so what I need to do is I need to parse this, which is essentially just a link, but with an exclamation point at the beginning, which makes it not parse as a link. So it doesn't show up as a link. Where in here, I put in which category it belongs to. But I can even do multiples, like this. Right, so if I do manual UI overview, it gives me this. If I do manual UI Windows, it does this, and this. So I need to detect these things, and I need to parse them, of course, and only show the important ones. I was gonna do that. I realized it would be cool to do it with regular expressions. Regular expressions can be so annoying. For example, if this was recursive, it would be a pain in the ass to do. But links in Markdown are not recursive, and I don't need this thing, which is similar to a link, but it doesn't work like a link. So it's not supposed to be recursive. That's not going to be a problem. So it should be possible to parse this with just a regular expression. And the thing is that there's maybe a few other places where it would be useful to have regular expressions instead of manually coding the logic for the specific parser, to instead code a regular expression parser. Thought that would be interesting. Might be, might not be. I guess we'll see. Alright. So I kinda have a feeling of how regular expressions are parsed. I would assume they use some kind of state machine. But I'm not entirely sure. So of course we're going to start with a little bit of research. Then we're going to create a very simple regular expression for this thing, and then we're going to use it. Who calls it regexp? Regexp. Or who calls it a rational expression? Who's irrational enough to do that shit? Nobody does that. Don't do that. Anyway, it does patterns in text. Yeah. It's used for string searching, find and replace operations, all that stuff. I don't find them particularly difficult to do, for that matter. I feel like people always struggle with them, and again, getting a regular expression that handles all the edge cases is a pain in the ass. But a very basic one, especially when you're doing like find and replace in an editor, simple to do. A regex or regex? A regular expression processor, okay, it is raining quite heavily, translates a regular expression in the above syntax. This shit. Okay, they are kind of unreadable, which I don't love. But, I'm used to them. So I'm okay with that, I guess. Whereas, for example, ANSI escape sequences I didn't want to do because I find them really unreadable. This is also pretty unreadable. Slightly less because it works directly with characters. And honestly, this is quite a complex one. But I guess it's either this or do a manual parser for what you want, which is what I was about to do, but then I was like, okay, let me do this instead. This feels probably gonna run into the same issue at some point or another, and it's better for me to do a regex parser. Alright, hold on, I left my window open. I'll be right back. Alright, I'm back, but we lost one along the way. Come on. Alright, he's here. Okay. I've prevented a flood in my living room, so that's good. Anyway. These shorts I'm wearing have like a really long string. Like, it's actually tied. That's really annoying. I accidentally hit Chester with it, so sorry about that, buddy. Now, if you weren't down there, if you were just in your seat, in your chair, in your low pillow, that wouldn't have happened. But I'm still sorry. Anyway, a regex processor. Okay, so yeah, it's supposed to do again what I believe it to be a finite automaton. So it's not a state machine; it is a finite automaton. Okay, using the Thompson's construction algorithm. This feels more complex than I would have thought, to be honest. I had a vague idea of how I was gonna do it today, and I definitely didn't think I was gonna have to be talking about Thompson. I don't know who Thompson is, but still. Wait, it's also called the McNaughton-Yamada-Thompson algorithm. Don't I always say that algorithms with 2 names are complex and 3 names are even more complex? That's kind of been the case, but not really. Ken Thompson. That's the Thompson, okay. That's the Thompson that we're talking about. Cool. Okay. Are we in for some bullshit? And this Mr. Unix. Well. Yes. I hope we're not in for some bullshit. But anyone who worked on Unix scares me. What can I say? Should I version control my resume on GitHub? Do you want people to see that you're adding little lies? Like yesterday you didn't have 10 years of experience in a 5-year-old programming language, now you do. That's a little suspicious. Maybe you don't want that. Regular expressions and non-deterministic finite automata are 2 representations of formal languages. For instance, text processing uses a regular expression to describe advanced search patterns, but NFAs are better suited for execution on a computer. Non-deterministic finite automata, right? Which, of course, you can make a non-deterministic finite automata into a deterministic one. Obviously. This low-key feels more complex than I thought it would be. Then again, they are complex. Oh, Stream Elements is in the fucking YouTube chat. It's never here. You don't actually have 30 years of experience in Zig? Shh, don't tell him that. Okay, so it works by recursively splitting an expression into its constituent sub-expressions. What is the pronunciation? Sub-expressions from which the NFA will be constructed using a set of rules. More precisely, from a regular expression E, the obtained automaton A with the transition function, is this lambda? It's not lambda. This is delta, right? I think that's delta. Respects the following properties. Oh my god, this is so formal. Can you just explain the damn thing to me? Nobody talks like this in computer algorithms. Okay, nobody fucking talks like this. Wikipedia, you need to stop talking like this. How does this algorithm work? Well, you see, given a regular expression E, and an automaton A, and the function delta, it has to respect the following properties. Tell me how it fucking works. Alright, give me the small example. That should be a good way to do that. This is genuinely more complex than I thought it would be. That's very interesting. The picture below shows the result of Thompson's construction. But then again, I wasn't planning on constructing any kind of structure to then parse the regex. I was more so planning on just like iterating over the regular expression and iterating over the string. Which I guess is just like same thing, but without this, but that also may have some limitations, I guess. Anyway, the picture below shows the result of Thompson's construction on this expression here. What the fuck kind of expression is that, brother? What is that expression? The purple oval corresponds to A. The teal oval corresponds to A star. The green oval corresponds to B. The orange oval corresponds to A star B. And the blue oval corresponds to E. Let me look at it. That's not even E. That's another weird-ass thing they got going on. Anyway. Beginning of the string is here. If E here, if E here. Do you think maybe you made some mistake? Is this symbol supposed to be everywhere? Does it represent something special? Does it have a specific meaning? Genuinely, what does it mean? What is that symbol that's literally everywhere? Like, how am I supposed to interpret this? If this value go here, if the same exact value go here, what does that mean? Anyway, and then if the same value here, if not here, but I do understand 0 may appear 0 times, in which case we only get, not 0 may appear 0 times. The expression is this shit, or A 0 or more times, followed by B. I still don't even understand what this symbol is supposed to be. Did it even make sense to the person who made it? I don't know about that. This is genuinely making no idea to me. Lambda, no, lambda is the little upside down Y symbol. Since a lot of programming languages use it, you could. Oh, the uppercase one is this. There you go. There's the Half-Life logo. This is epsilon. Yeah, that's epsilon. I just don't understand why it's on every single branch of this graph. Is that a mistake that you made, or what? Because I kind of understand the graph. The empty word? But why is it on both of these? Also, what kind of regular expression has this to represent nothing? Again, this feels like I wouldn't do it like this. But how soon would I run into limitations of just doing it in a more naive way? Probably, you know. They wouldn't have done all this shit if they didn't need to. But anyway, our expression is apparently empty. Is that what epsilon mean? Epsilon in lambda. Jester, you can't lay there. If I move the chair, I'm gonna step on your toes. That just healed. In lambda. What the hell? In regex. This is a lot more mathematical than I expected it to be. What are we going on about? It's not even that it's more complex than I expected it to be. It's just that they love bringing mathematics into this shit that nobody actually uses. Nobody talks in mathematical terms. Nobody describes an algorithm by saying, given a regular expression E and an automaton A with a transition function this, respect the following properties. Nobody talks about algorithms this way. This makes zero sense to anyone except for somebody who knows mathematics. Or the mathematical expressions. Can we not do that? We don't use these symbols. We don't use these formalisms in programming. We're talking about an algorithm used in computer programming. Can we talk about it in pseudocode, maybe? Okay, so still trying to interpret it. We can have a 0 or more times, right? So of course we can have a, and then we check again if we have a, then we check again if we have a, until we eventually have something that isn't a. Or we may not have a at all, so we could just skip a and go over b. To b, I mean. To expect the character b. Which at the end of the a star part, we can also have that. And after we find b, okay, I'm starting to understand how this graph is structured. We have the end. I think I understand, just because of the fact that we start here, right? So again, what is this branching thing here with the same condition on both? That makes no sense to me, but whatever. Ignoring that, ignoring this, we're here. We find A, we go here. But we don't find A, and we have nowhere to go. So that doesn't make much sense. Oh my god. You've got to be kidding me with this. Genuinely impossible to understand graph. Again, unless you know, like, I don't know, what is that called? Like set theory or whatever the fuck mathematical concept I flunked out of. That thing. Math is literally the reason I dropped out of college, by the way. We did so much math, so little programming, so little anything that's actually useful to programming. But then we have people who love to define shit by the most pedantic language possible. So how about we just don't do that? How about we just ignore that? Anyway. Somehow, despite it raining, it's hot as shit in here. That's really annoying. Also, there's like a dog blocking my fan, so that's not helping either. Some dog. I don't know who he is. As an example, the picture shows the result of Thomson algorithm over the regular expression 0, 1, 0, 1. Why would you do it over this fuck-ass expression? Why would you do it over that? Could you not make it anything more comprehensible than that? Are you serious? This is gatekeeping. This is actual gatekeeping. What the shit? You're literally gonna be parsing fucking zeros and ones, by the way, in this fuck-ass expression. Like, yeah, if I sat down, I could understand it. We got the 0 or everything else that comes here. Then we got... Do you see how hard it is to read, though? How hard this shit is to read? Because pretty sure this parenthesis matches here. So we got 0 or this fuck-ass thing. All of that 0 or more times. Then this fuck-ass thing, 0 or more times, starts with a 1, followed by a 0, 1, where the 1 is repeated 0 or more times, followed by 0, 0, repeated 0 or more times, followed by 0. This whole thing, 0 or more times, followed by a 1. Did you understand any of that? Because I was reading it. I was parsing the damn thing in my brain, and I did not understand a single goddamn thing of what it means. Because they made it intentionally meaningless. You're parsing two numbers. You could have done a fucking, like, any kind of regular expressions like these. Even this one is super complex too, for that matter. But you could have done this one, maybe. Ridiculous. Ridiculous. Can we do it without these algorithms? Like, regular expressions can get this complicated. They can. And then you need to be able to parse them properly. But when you're explaining the algorithm to someone, maybe don't use the same two symbols everywhere. Maybe don't use symbols that you haven't explained, that I don't even know how to type in my keyboard. And that then you meaninglessly use everywhere. That was a simple example. Let's see the more complex one. Look at it, look at it. This is the automaton. This is the result of it. Look at it. It's so simple. Compared to this fuck-ass thing. Sure. Could you maybe have used a more readable example, though? Would that have been too difficult for you to do? Can you now show us how smart you are if you do it with a more easy example? What was it that Terry Davis said about, like, complexity? I forgot what it was, but I think it applies here. Send OpenAI request to regexify. See, we're parsing the regex, it's not creating them. I find creating them particularly easy. Alright, so the regular expression that we're going to use today, we're going to start with an exclamation point, followed by this symbol, which I'm going to need to escape because the symbol is used in actual regular expressions, followed by any symbol that isn't the closing symbol. And now you can see where I'm using them. The white brackets are the ones that are part of the regular expression. The green ones are the escaped ones where I'm actually using the character. That 0 or more times, followed by the closing bracket, followed by a parenthesis, which I also need to escape, followed by, I'm going to need to make this a little bit more complex eventually, but it's going to be anything that isn't a closing parenthesis for now, followed by a closing parenthesis, without escaping. What did I do wrong? Yeah, 0 more times on this. No? What did I do wrong? There we go. There we go. And there you have it. The regular expression itself. Quite unreadable. I'm gonna be so honest with you. That is quite unreadable. But I am familiar with regular expressions. I know how to work with them. I've just never parsed them and executed them myself, which is what we're gonna do. The regular expression itself is pretty easy to work with. Alright. I'm gonna do this thing. Like, I'm not gonna bother with Thompson here. Wait, I genuinely said we're gonna be up to some bullshit. I don't think the algorithm is bullshit. I just think the explanation does. Maybe like Geeks for Geeks have a better explanation. These guys tend to have pretty good explanations of like Thompson's algorithm. They tend to have pretty good explanations of algorithms, especially with a lot of graphs that actually make sense, where they explain everything. Though they only have anything on Thompson's sampling. Did I call it wrong? Thompson's construction, maybe? Construction? Surprised they don't have that. They gotta have that. See, that symbol is a symbol on this shit. This shit is similar to the NFA, but with the minor difference by epsilon move. So I'm supposed to read all this before. This automaton replaces the transition function with one that allows the empty string as a possible input. The transitions without consuming an input symbol are called... Was it so hard to explain this, Wikipedia? This is suddenly making sense. These transitions that are all over the place are... I'm looking so white right now. Transitions that don't consume a token. So we move between this or this, but without moving forward in the string. Was it too hard to explain this shit? Just very quickly looking at everything here. It's not the first one, is it? Yes, it is. Okay. The tabs are giving you anxiety. These? What's wrong with them? Create a single start state for the automaton and mark it as the initial state. For each character in the regular expression, create a new state and add an edge between the previous state and the new state with the character as the label. For each operator in the regular expression, such as asterisk, which is 0 or more, plus, which is 1 or more, or question mark, which is 0 or 1, so optional, if you will, create new states and add the appropriate edges to represent the operator. Mark the final state as the accepting state, which is the state that is reached when the regular expression is fully matched. Did you see how easy this was to understand? So this was written by computer programmers, and this shit was written by mathematicians. Okay, now that does beg me the question. That's not a thing. That does beg the question of, do we really need to build this before we start parsing, or can we parse and build a thing at the same time? Or probably better not to do it like that, because optimizations, you're not creating the regular expression every time, you just create the automaton once. That sounds reasonable. But I'm assuming technically, yes, you could. If you're parsing one time, but if you're parsing multiple times, like is going to be the case here, you probably just want to build it one time. So, okay. I get it. Essentially, for every part of the regular expression, we're going to start with an initial state. So, we're going to be an initial state. For every character of the expression, we are going to give it a state, right? So, we have a new state, which we go to if we encounter the exclamation point character, since that's the first character that we expect. This is a sequential one that doesn't have options, so that's going to make it particularly easy. So how do you handle options? Well, to be fair, those are usually within parentheses. I don't know. I feel like there's going to be some backtracking because of that, but anyway. Then I'm supposed to find this character. So again, very simple. Same thing happens, right? Did I just copy you? I think I copied, but I didn't paste. Anyway, we're going to encounter the opening character. At which point, we're going to check any character that isn't this. So how do we represent this? Another state. And maybe we can even do not this. And this happens, I'm just going to draw this one manually. 0 or more times. Or yeah, okay. Until eventually we encounter this character, the closing character, at which point we're now in this state. We go to parenthesis, no, opening parenthesis. Don't know why I'm building it like that, just kind of folding over itself. Opening parenthesis, followed by anything that isn't a closing parenthesis, over itself again, 0 or more times, followed by a closing parenthesis. So you can tell I gave up on using the symbols, and it becomes uglier and uglier as I go along. Oh well. But I think, yeah, that is how I would construct this thing. Makes sense, seems reasonable, seems easy enough. And of course, the slightly complex thing about it is, based on just this very basic explanation, I was able to build that just fine. But how would I do it for this thing? A or B? Like, how do I know which state to go to? Is the question. And maybe I'm just like misinterpreting how they would use this. Like you're running this check and this check at the same time, right? I'm just struggling to understand that, because that's how it would work. If I find an A, I'm in this state. If I find a B, I'm in this state, which means I need to check these two states at the same time. That's how it feels to me. I feel like maybe the visual representation isn't the easiest to understand. Because if I had to represent this thing, let me do it again. It would be like starting point, right? We transition to having found any character, or this character specifically. From there, we transition to having found this character specifically. Any character that isn't this, that's how I would visually represent this. But yeah, I guess maybe from a code point of view, it makes more sense to represent it like that. I don't know. Let me try it. I am basing this off of a very simple, an unreadable regular expression, but a very simple regular expression. It's just this character followed by this character followed by anything that isn't this character. So just to invert the condition, followed by this character 0 or more times, followed by this character, anything that isn't this one 0 or more times, this character. There's no branching, there's no ORs, there's no recursion. There are capture groups, which I technically haven't included in here, by the way. Also, when you use a parenthesis, this should have gone into a capture group, actually. Wait, did you delete my shit? Yeah. Not sure why, but whatever. Yeah, this stuff goes in a capture group because we need to parse it further. And this stuff goes in a capture group because that is the actual text that we're going to show. Could A or B not mean find both? And if one is true, the answer is true? Like A or gate? Kind of. NFA meaning non-deterministic. I will always choose the correct path. How is the question that I have, I guess, but okay. Yeah. Let me see, do they have a walkthrough of how they would do it? Not really. Okay, their expression is actually this one. It's slightly more complicated. First, to create the one for, which again, now I understand. I just don't understand. How do I know which path to go through? I'm at this state. How do I know which one to go to without checking their transitions? I'm checking their transitions, which means consuming a token, right? So essentially, why not just represent it like this? This is how I would represent it. That feels more reasonable to me. I'm here. I encounter a character. Is it A? I go down this transition. Is it B? I go down this transition. That feels reasonable to me. This does not, because I'm here. How do I know which one to go to? That IDK. Can't say I understand that. Because I genuinely just want to build it like this. This feels like a very reasonable way of building it. For that matter, I've done some pattern matching like this. For that matter, wouldn't Lisp be great for this? Not really, not really, not really. Whatever, the language you use doesn't matter. Maybe I'll just make version 2 with Lisp. I can't really integrate Lisp into this damn thing, so hardly a problem. Anyway, how about just for the sake of it, I do it in its own project? Nah, there's no need, there's no need. Yeah, whatever, what the hell. Just create a new project for it. Alright. Pretty sure I could have created the folder from here. Or not. Apparently not. Oh, here, okay. That's a very hidden button, but whatever. Regex. Here we are. Alright, we're gonna give you a build.redb file. So we have a build system. We're gonna give you a main function, and your main function is just going to take a regex.c and a tester.c. It's gonna source those two. No, it's a little more complex than that. It's a new module. By the way, tomorrow I'm remaking this thing in Lisp. Build system is okay, but requires a little bit too much boilerplate. Also, the actual code for it is a mess. Alright, so set name, package type, should be a library to be fair, but actually this is perfect. The perfect little template to copy and base it on. Okay. Jester, move. No, 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 you cannot be there. No. Almost stepped on him. Alright. Does this not have any includes? Oh, I skipped them. Okay. Alright, gonna continue project setup. And there's gonna be an ad running during that time. So, don't fear. It's just a 3-minute ad. regex demo. All right, we're gonna build either a not package, just a binary, or a library file. We're going to target native for the time being, and we're going to source the regular expression.c file, as well as the tester file, which is going to be passed as an argument here. We're going to compile, generate a compile commands file, and if we have a source file, we're going to run what we have. Otherwise, we're just going to generate a library. And we're going to print this and return, and that's it. And bada bing, and bada boom, and a tester.k. You're creating an epsilon NFA, while for a concrete implementation, you will use a DFA as a reference, since the implementation is, of course, deterministic. Why would they do that? Why the fuck would you do? Which is, yeah, okay, you're right about that, which is then made deterministic, and the resulting deterministic finite automaton is run on the target text string to recognize substrings. But why go through that step? Isn't the way that I wanted to implement it just a lot easier? I mean, I'm going to try to do it like that, and if I run into any issues, I'll understand why they came to this conclusion. This feels a little weird to me. Also, this is helpful. The very basics of regular expressions. We have OR, which is the vertical bar. This, gray or gray. Why would you do it like this when you could do gr, e, or a like that? Whatever. Parentheses are used to define the scope and precedence of the operators among other uses. Oh, there it is. They're equivalent patterns, which will both describe gray or gray. A quantifier after an element, such as a token, character, or group, specifies how many times the preceding element is allowed to repeat. We have the optional 0 or 1, we have 0 or more, and 1 or more. We have this many times, minimum this many times, maximum this many times, minimum, maximum this many times. Dot matches any character. And this is about like being greedy, if I'm not mistaken, right? So dot matches anything, single character. No, it matches a single character, and then B, and then the other one matches A, single character 0 or more times, and then B. So yeah, it's about how many characters in between. Or you could use a dot plus to match A, any character B. These constructs can be combined to form arbitrarily complex expressions, much like one can construct arithmetic expressions from numbers and the operations plus, minus, dot, multiplication, and division. The precise syntax for the regular expression varies among tools and context. More details given in syntax. In the example, there was something about minimize DFA. In this one? Oh yeah, here it is. Minimization. I just don't understand, why wouldn't you build it deterministic in the first place? The way that I feel like building it feels easier, simpler, better. But maybe I'm just a better programmer than Ken Thompson. No, okay. I don't think that's what's going on here. And I'm probably going to run into some issue that's going to make it obvious why they do it this way. Or I'm not. And I'm never going to understand why, but my implementation is going to work and whatever. We're just going to move on from this whole thing. An NFA can have 0, 1, or more than one move from a given state on a given input symbol. And an NFA can also have null moves. On the other hand, the DFA has only one move from a given state or a given input symbol. It feels overly complicated for it. I don't know about this, man. I don't know about this. I forgot this was running the whole time. Anyway, regex right now is going to have nothing. You are going to have a syscall call... Right, we don't actually have a... compile commands, so Clang has no idea what's happening. I forgot to change the name of this function from uno to regex. Alright, there we go. Now I should be able to build. And we got a hello world. Very good. Alright. Alright, let me start building this thing. Which, by the way, I forgot to... nope. regex.h. Doesn't get compiled, but it is the header for our regular expression function thingy. Maybe once I'm done with this, I'll eventually have to figure out how to include external dependencies into my system. Because right now I have one as a submodule. Do I want to keep doing that? Probably. But also, this uses this build system. Although, that may change tomorrow, the way that works. I don't know. This probably won't be implemented yet. Anyway, what do we have? We're going to have a void init regex with a const char pattern. And that is probably going to give us some kind of regex handler. Whatever goes in that. Probably the pattern itself. Maybe a string copy in the pattern. The resolved automaton. I don't know. Anyway, then we're going to do a boolean parse how do I want to structure it? There's going to be a few things that I wanted to have. Since I'm designing the interface, that was lightning. That was very nice. First off, you can choose to find one pattern or continue. Then, yeah, okay, so I'm just going to do different functions for that. Okay, so it's going to be something like regex find one in a string slice, which is going to be our string str, and then we're going to need a regex handle, which is the one that we created. And this will need to give us some kind of result, because not only do we need to match, but sometimes we need to capture. Capture groups are kind of necessary for what I'm doing. So we will have another typedef struct called the regex result. And that is going to be what you return. Which starts with a boolean found. Alright, Clang seems to be working now. I also need to include string slices. Alright, so we're going to have find one or find many. Where find many is just going to do a boolean return and a void function pointer called onFind, which gets a regex result argument to it. What else is the regex result going to need? It's going to need a range, which is a type that I was using yesterday in the terminal. There's ranges, but I don't remember where I implemented them. They should probably be a type. Are they a graphic type? No. Let me see in the terminal. Which by the way, might be ready to commit the code for the terminal. I'm not sure yet. The problem is, since it makes the other one unusable, I should just do it in its own branch at this point. Yeah, actually, you know what? I'm just gonna take a second to do that real quick. I'm gonna mark it as work in progress. And the docs for the UI, we have that. And another thing that I added is lib and program names. I was blanking on that. Okay. Get checkout branch new term. All right, we're now on that branch. We're gonna commit that. We're gonna publish it to Codeberg. It's gonna take a bit. The ID is Z. It's gonna take a long time, god damn it. And then we're also going to push to GitHub. I'm going to need to figure out this whole like double repo shit because it's really annoying. Sometimes I only push to one, not the other, and it's really annoying when I shut down this computer, try to get work done on my laptop, and yeah. Anyway, good to have that. The shared library is already done. I don't need anything else from the terminal, from the OS right now. I'm doing it separate for the time being. Because the redlib library is starting to grow really big and it's really annoying. But again, I need to figure out a simple way to introduce this library into this one somehow. Do I want to publish it? Do I want to just have a million submodules for the different libraries that I do? I'm not sure how I want to handle it. So I'll have to consider it. And the thing I went to the OS for was range. Where is that defined? Here. It's in text draw. No. Come with me. You're going to types. Range is a pretty useful type to the point that I was actually considering having ranges be parsable in string, be printable in strings by doing this. So yeah. Anyway, ranges there. And one thing that I forgot is that you, of course, need to fetch and pull commit or stash them. Are you serious? You cannot be this stupid. There was no reason for me to do that. No conflicts with what I just did. Git just didn't feel like pulling. God, is it useless. No, not Git. That was supposed to be make clean. VS Code automatically does a stash and Z doesn't? Did not know that actually. Alright, I before I continue doing this in its own library, I have to consider this. We have the OS, right, which has its own code. But then it also pulls from a shared library, which is a separate repository. And this contains way too much stuff. But now I want to integrate more stuff into it, such as the regex library. This is a separate library. Do I make it a submodule of shared? Do I make it a submodule of the OS? Do I make it because this is technically the core library. So this is a separate library, then it shouldn't be a submodule of this one. It should be a submodule of the OS. The entire point is for me to fragment it a little bit more so I don't have a giant library, which I already do, but yeah, fragmenting it a little bit. So it should be a submodule of the OS. And then the other possibility is, do I want it to be a submodule or do I want it to come pre-compiled? But probably a submodule is fine. The issue is that this doesn't have a makefile. But I'm working on my build system tomorrow, so I'll figure that out. Might just make a makefile or even just a bash script. IDK. VS Code does git pull autostash. I feel like we already saw that happening. Interesting. Alright. I'm sorry, but this has to be range T. I hate T, but yeah, needs to be. Which means that anywhere I was using range, such as the draw library, will now become range T. Here and here, and here, and here. And in the operating system, but this is technically a submodule, so I don't have that problem. Yeah, I think I'm gonna do submodules and compile manually. And I'll find a way to make this also compile to a makefile, perhaps. Since the entire idea of rebuilding the build system with Lisp is that it kind of knows what it's doing. It's supposed to be like aware of the build process that it's doing. So could already do that with the current one, but it would be easier to do with this one. Definitely, the entire build system right now is just lists, and Lisp is great for that. So yeah. Git config merge autostash true. I feel like we already talked about this, so. Damn it. Alright. Thank you for that. We're building a regex engine, or not, because what I want to do seems a lot simpler than what they describe on Wikipedia and Geeks for Geeks, but it seems, I don't know, I feel like I'm skipping a step over what they're doing, but to me it seems easier. And again, with so much mathematical language, maybe what I wanted to do is just skip straight to the point. I don't know. Anyway, yeah, a result is probably going to have a range, and it's going to have whether it's found or not, and eventually it's going to have capture groups, which is probably going to be like a linked list of ranges. Unless there's a maximum number of captures. Yeah, regex engines do a compilation step. But this is kind of two compilation steps. First, you build a non-deterministic graph, and then you turn it into a deterministic one. Whereas, why do I need to do this part instead of just doing this one directly? That's what it feels like to me. Anyway. Do regular expressions have a maximum of capture groups? Because if they do, that makes this a lot easier. Also, linked list is definitely not the way to go. I would probably use something like a chunk array, which is a growing array, but it doesn't even need to be a chunk array. It's a list of ranges. So whenever I misclick, I accidentally click on the chat and scroll it. So this probably doesn't need to be a list. It can probably just be something like this with a or capture count. Probably that's gonna be enough. Yeah, I don't think it matters too much if there's a limit or not. I don't think you're gonna get to a huge amount, but with a result like this, I can just... I'm not giving you a pointer, am I? Yeah, that changes everything. Alright, capture groups are not as concerned right now, but they will be because I do need them for the actual thing that I'm building. So right now I'm just creating the interface of this library. It's going to have this, and then I want to have this with regex implementation, because another big advantage of moving libraries to their own thing is that maybe regex isn't going to be so important, but maybe also yes. I can replace my implementation of something with another implementation of it if I need to. This can be useful for compression. This can be useful for encryption. This can be useful for networking. So it would be nice to be able to do this. The problem is any code that I write in here, Z is not going to realize that I am defining this thing. Even though I can tell it. Which again, my current build system does not have a knowledge of compilation steps. If I'm not mistaken, my compiler does use them. Not compilation steps, like condition compilation, I mean. My compiler does use them, so let me see how I implemented them. Because they're kind of hacked together, I'm not gonna lie. Very much hacked together. Also, I turned on show hidden files and yeah, here. Oh no, it is. It does have a knowledge of what it is. Add pre-comp flag. Is pre-compilation the name of it? Preprocessor is the name of the thing. Whatever. Alright, so... And the compilation flag is regex implementation. And we're going to include it. And we are going to implement these functions, whereas somewhere else we can have a regex wrapper, where these functions are implemented as wrappers around another library. That's the entire point of the conditional compilation here, but will this even work? Like I can write code here, but I'm not gonna get any code completion. And I don't know about this one. Alright, the only way to know is to compile it. Alright. Compile commands now has the build system and cross compilation flag, as well as... Oh, it's straight up not here. Ah, wait. No, that failed, hold on. Unknown type regex handle. Oh, wait, you're not? Alright, that compiles. And here is our compilation flag. We're giving it to the compile commands JSON, and it does not see it. Clang does not see it. Por el amor de Cristo, por favor. So that means all my code is going to be grayed out while I write it, and I'm not going to have any Clang functionality unless I do this shit. For the love of God, Clang is such a clanger. Also, yes, everyone just has their own slightly different flavor of regex. If you go to like a regex tester, they usually have the flavor, all of these. And this is not most of them. This is PHP, JavaScript, Python, Golang, Java, C#, Rust, and PCRE. I'm pretty sure it's probably more. Because everyone just has their own implementation, like I said. Okay. Okay. We're going to print the pattern, and we're done writing boilerplate. It's been a lot of boilerplate. It's finally time to get started on this thing. Just need to write the last little part to init a regular expression with... Do we want to go super complicated? No, I just want to go with a sequence of characters to match. No operators on that yet. Just build the sequence itself. So for now, we're just going to do this, this, and this. Which... Unknown escape sequence. Clang, shut the fuck up. Your mom's an unknown escape sequence. Alright, this is very much a known escape sequence in a regular expression. There's just no way to tell you that this is a regular expression. So, fuck off. This is also a valid regular expression, right? Just one that is empty inside. Let's do hello. Alright. And then I expect you to give me a regex handle. And I'm going to do match. Did I not call it match? What did I call it? Yo, Mary Dunk. What's up? Find one. Okay, so it's regex find one using this handle and a slice from literal that is going to be this, 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 and this. This is not a regular expression, so we will not need to escape. This will give us a regex result. If the result 1 fails, then that's an error. It's going to tell me that it failed and return a -1. And we're going to do the same thing with another string, but we're going to invert the condition, right? This is supposed to match something else, like it's just heyo. And if that is found, then clearly shouldn't have matched. That is technically valid, I think. Would an English regular expression parse that? Also, imagine what an English regular expression would look like. Obviously, you wouldn't do that, but like imagine that. Just want to put that eldritch horror in your head. All right, we get to the end, and we did it. We did it. All right, so string 1 should have matched, so that clearly fails. Funnily enough, if we just skip this part, string 2 won't match, so we're good. We can even do a test passed. Although it won't pass. All right. Now, we do have to have a parser for the pattern that we then use to parse, which is interesting. It's definitely interesting. But For the sake of simplicity, most likely the regular expression is going to be hard-coded, which is why I'm using const pattern, const char pointer here. But I am going to turn it into a slice because it's easier for me to work with. Instead of you having to call this every time, I call it one. It's better. It's easier. I'm counting on regular expressions being mostly hard-coded. That would make sense. All right. So the very simple version of this is that we're just going to go over our string with the pattern length and expecting a character, which is going to be pattern SL data I. And then that's going to return a handle, which we haven't even decided what it's going to look like. So in this case, it's exactly what we expect. We expect to find this, followed by this, followed by this, followed by this, followed by this, this. Okay. So this is where I start constructing a node. A node for this thing, a graph for this thing. And let me quickly go through my data structures. Shouldn't be a backlash in there. No. Those are escaped characters, so they count as just one character. Even though it doesn't recognize it, it understands that this is an escape sequence, so the backlash doesn't make it into it. But then how could you tell the difference? That's a good point. Like, what's the difference between this one and this one? Because at some point I'm actually going to have this. And then this and this are different. Hold on. Hey, that's the title of the stream. Does C have a built-in regular expression? POSIX library? Are you serious? Okay. What is this crap? Oh god, they have C-style regular expressions. You know, the thing is, some languages I have seen that you do need to escape the backlash. The backslash, not the backlash. Okay. So that is exactly accurate. Also here. In some languages, you actually have to do this. I feel like Swift is like that. I just don't remember if it's still like that or not. Whereas other languages sometimes even allow you to specify what kind of string this is. Like this, maybe. And that already kind of... The compiler understands a few things and knows how to structure your string properly. Does this manually, essentially. But yeah, this is exactly what I would expect the string to look like. Which is funny, because then... Hold on, now how do I use this character? What if I want to match this character? Do I need to do it 3 times? I need to do it 3 times. But that requires me to do it 4 times. Yes. I need to do it 4 times in order to catch this character alone. Because if I do it 1 time, that is going to escape the end of the string or whatever comes next. Which means this is actually not part of the string. So I escape it. And that technically looks correct, right? The problem is, my regex parser is going to be like, okay, I encountered this character, which means the next character I encounter is not part of the regular expression, it is part of, it is literal, right? Which again, when it encounters this character, because of this one, it's like, oh, you're not starting a group here, you're literally expecting this character. Got it. So of course, when it finds this, that's an error. So I need to escape the escape, which requires me to add 2 more. Because if I add 1 more, we end up with the same issue, so I need to add it twice. And now, the way that my parser sees it, it's like, oh, I found one of these, which means the next character isn't telling me something about the structure of the regex, it's telling me how the literal character. Literal character. Special strings? Right, that's true, they have special strings. They tend to do this. But I don't think that will work here. Yeah. No, to be fair, I haven't finished it. C is not like that, and again, look at the POSIX regular expressions. Look at them. They're ridiculous. These are absolutely ridiculous. What is that? Come on, man. Absurdity going on. Alright. So yeah, you know what? Let's match that character. We expect to match that character, right? That way I can test this case as well. They use bracket. Yeah, but they're... Because this is well, I closed it already. But it is entirely different from how other languages do regular expressions. I wouldn't even call those regular expressions in the same sense. Like when I go here and I click on... no. I click on this, use regular expressions. I wouldn't be able to use that thing that C uses. So it's completely different. I did say Unix has some bullshit going on. And it did. Okay. So, the way we read this is correct. Right? We're expecting this, but the escape characters are the first ones that we're going to consider to be a special kind of character, right? So, next character is going to be this one. And then we can... No, I'm not going to use a switch, because the condition is going to be a little more complicated, since there is an ignore next control. Ignore next, actually. Just that. Off by default. Alright. And if not ignore next, then we're going to try to parse the special characters. The first one, and the only one, is the case if the character is an escape. Deleted everything there. If that's the case, we do ignore next, and we continue. Which means this escape will disappear, this escape will disappear, this escape will disappear, but this one should stay there. Not quite. Oh, because I'm never resetting ignore next at the end, so it should set itself to 0. Okay, there we go. Yeah, some regular expressions do have like shorthands and whatnot. I feel like the compiler is going to complain about those. Not sure. There's a reason that POSIX does it like that, whereas other languages do it the way that they do it. But I want a regular expression parser for C, even though it means making your syntax a little bit more backlashy. Whatever. You have to, yeah, double escape, pretty much. You have to do that. Though, this is technically a... No, it's not an unknown sequence. Alright, never mind. Alright, so we have the first one of our escape characters, which means that, and it does work, a special control character, which means that we don't expect, we don't treat this one as controlling the pattern, but as a literal character. Alright, so that works as I expected it to. A very good. Now, again, the way that I want to build this stuff is with a very basic kind of a very basic kind of structure, which is probably gonna need to go above the handle because the handle will control it, contain it. No, not state. No, node is fine. Node is fine. It's going to need to have some sort of rule, which I'm also going to need to type def struct regex rule. Who knows if I'm over-engineering this thing a little bit? I'm already creating 3 completely empty type defs. Feels that way a little bit. Anyway, rule. And then maybe one simple way to do it would be to have a pointer to another regex node for when it succeeds, and another one for when it fails. Success. But that would build it different than I did before. See, I did say maybe eventually I'll come into some realization as to why it's better to build in a certain way. What's the pattern that we're trying to match? No, we're good. Hold on. Right now we only match literal characters. Eventually we'll need to be able to match more complex patterns, like anything except for this character, which can easily be done as invert, or anything except for this set of characters, right? Because sometimes sets of characters can also be part of a rule. I'm gonna try to build it like this. Because it feels a lot easier to have every node just have 2 states that it can go to, whether it fails or whether it succeeds. But it does require me to move it, and honestly, I can't be bothered with drawing the whole thing again. If you could make a macro, I don't think you can make a macro for that. Macros inside of, nah, I don't think you can. Nah, probably not. Anyway. Building a regex. I still don't know how to pronounce it.
Regex.
Are you sure about that?
Regex.
Regular expression. Register expression. So it's a regular expression. I feel like I'm getting into some GIF territory here, so I'm just gonna shut up and call it a regex. I always call it regex. Today I'm calling it regex. It's the spirit of reggae taking over me. I don't fucking know. Anyway. Okay. I'm going to try to build it like this, and if it doesn't work, well, I guess we'll fix it. That's the entire point of coding without bothering too much about how you're supposed to do things, right? That's the cool thing about it. All right. I am from Spain. I live in Spain anyway. All right. So the way that I'm building it requires me to build it backwards, doesn't it? No, maybe not. Maybe not. I'm going to take a node, current or previous node even. It's going to be empty by default. And I feel like this needs a little bit more recursion. Whereas I'm just going through the string like this, I'm probably going to need to recurse within it a little bit more. I don't know. There is one thing I'm going to try, though. That way you can have it as both a slice or a literal. I feel like I'm over-engineering the interface of the library more than the library, like more than the actual stuff that it's supposed to do. Whatever. Anyway, we're going to construct a current node for whatever we're trying to get. Okay, so this is for like control characters and whatnot. So once we get here, once we get to this point, then we're probably going to add something to the chain that we're supposed to be building that I don't think we're actually building, but I'm not sure. Anyway, we only allow one type of thing, which is matching an exact character. And that would be this one, next char, which I'm somehow not using here. So to the node, literal is next char, invert no, and that is it. That is it. That's the only rule we currently have. We match literals. And then probably better if I do allocate these nodes. Probably better to do it in like a sequential manner, but for now this is fine. Yeah, so I can use pointers to these nodes that are always going to be the same. I'm going to have a root node, and that's going to be the previous node. Wait, no, there should be no root node. So this initializes at 0. I needed a boolean before, now I don't. Okay, so we're going to create a new node. We're going to tell it your rule is this literal that you're supposed to expect. And if we have a previous node, then when we succeed, we make the previous node's success. That's spelled wrong. Hold on. Success into the node that we just allocated. There's currently no failure. See, yeah, new languages have that R at the beginning of the string. I saw Lisp actually has like P or something at the beginning of the string to indicate that it's a path. I forgot what it is right now. I wrote it the other day. What's up, PZK? Alright, so again, this very simple regular expression is gonna work with this, I believe. And the previous node is going to be set to this one. That way we're gonna create a chain. And of course, we also need to keep track of which one is the root. This can be like that. So that if we don't have a handle root, we assign it to this node as well. All right. So essentially, we're just creating a link between all of these. Can we know for sure? We can give it a try. How do you need this level in C? You just write it. You just write C until you reach it. All right, then we go straight through the handle and we just get a node, which is going to be the handle root. And then while current node, we're going to print the value of it, current node dot literal, and then we're going to make the current node equal to the current node's success. So kind of a linked list in the sense that it's exactly a linked list. But it only matched one. All right. I'm only assigning a value if it's already assigned. That didn't make a whole lot of sense. All right, so here we have our very basic chain where it expects to very much match everything like one character after the other, no modifiers, no special rules, no nothing. So far, so good. Of course, we're going to need to do something a little bit more complex than that. But before we do something a little bit more complex than that, we're already calling this function. And of course, we do expect it to match. So let's make it like an LLM and make something that isn't really working, but it passes the very basic tests that we created, so it looks like it's working. All right. First off, if we don't have a handle, we're going to return. We're going to return an empty result. Or if our string doesn't have a link to. All right. Then we're going to do something similar to this pretty much, but not quite like that. We're essentially not going to use a while loop. I believe what we're going to do is use a for loop over the string length, and I'm surprised it's not complaining about signage of this versus this. This is unsigned, this is signed. Why are you not complaining? Oh, I don't have a strict enabled, that's the thing. If no handle or no handle root. Yeah, the way that you get to this level of C is you just write C and you just continue writing it. You just continue writing code until you get to a good point of it. And then you keep going. Eventually, you end up breaking down bigger problems into smaller ones and getting to this point, and yeah. Alright. So, we're also just going to hold a result type here. Equal to this, and that's what we're going to be returning. We're going to be optimistic probably and say that we did find a result. And do you hear that the US government made Claude suspend access to Fable and Mythos? Yes. I talked about it yesterday. It's really funny, but on the other hand, the US government is horrible. So it's like awkward laughter. Alright, here's the check that we're gonna do. We have a current node, right? So if we don't have a current node, if at any point we don't have a current node, then we're gonna set the current node to be the handle's root. We reset back to the beginning, right? So even here, we can have an uninitial, well, not uninitialized, but like zero initialized current node. Right, so we begin here. Now, if the current node is the handle's root, this condition will be helpful in a minute, but I don't think we need it right now. We need to check if the current node's literal is equal to the string's data I character. If that's the case, we did it. The current node, well, we didn't do it. The current node becomes the, if there is a success, then the current node becomes that. Success state, we got that one. Otherwise, with the current rules that we have, we got to the end of the string. In which case we can say result.found equal true, result range dot no, the start gets set later. The size gets set by whatever is the start, I minus whatever is the start. And this is where you're going to complain about size. I knew it, I knew it, I knew it. Oh wait, no, hold on. Start. That is, if we managed to find a character, but there's more characters to match, we move on. If it didn't manage to find a character, no, if we did manage to find a character, but we we did manage to find a character, but there's no more characters to match, we got to the end. So we save the result and we break out of the loop in case there's any more stuff we need to do. But for the time being, I think we're good. And then we have the case where they don't match. What happens if they don't match? By the way, we're gonna make this false by default. Well, if they don't match, but we're at the beginning node, the root node, then nothing really happens. So we need to check that this condition isn't true. That means we've already matched some, but now we failed. Well, if we have a failure state, we go to that one. And if we don't have a failure state, then we failed entirely. But really, all we have to do is set the current node to 0. Next time it will be reset and break. No, not break. Continue. Continue. I think. I hope. Also, this is I implemented in the find one. There's an add break right now, so I'm just gonna quickly implement it in the find many. I'm just gonna copy all this code and just change the way that it works. The thing is, we don't break and there is actually another condition that I forgot here. If the current node is the root node and we found the beginning character, then we have to set the start to I, the current character. Alright, back to what I was doing. Yeah. We don't break. We will continue. But before we continue, we will call onFind with the current result for them to manage. We don't return the result. We return a boolean if ever found false, and whenever we get here, ever found is set to true. And then when we're here, result is going to be reset. Before we continue. And also this one. And we return ever found. Alright, so that's how you handle that. Here you just return false without ever calling this. How stupid of me. I'm gonna make this a boolean for the sake of it. It will continue or break, right? Return true means continue, return false means break. That is, if no onFind, then you are gonna break. But if you return true, then we try to find another one. That way, I can call find many from find one using the same handle, the same string, and the regex find one handler, which is going to be a boolean function called that whole last thing, which takes a regex result, returns false, and then sets this regex result, find one result, to this, and returns find one result. Will that work in terms of memory? I'm not sure. I guess I'll see. And also the find one result will need to be reset every time. Yeah, working with lambdas on C isn't amazing, but whatever, it works. Yeah, I heard that Oliver Tree died. That was very unexpected, but yeah, I heard about it. Um, all right. Is all the code there? No, clearly not. Found C instead of expected. Current node literal. And what's the name of the current character? The name of the current character is str data I. Alright, so you're gonna print that. Tell me where you failed. Nowhere, apparently. Interesting. Oh wait, this shouldn't be here, for sure. But I don't think that affected anything. Alright, current node literal versus str data I. Am I even calling this in the first place? I swear to God. No, I am calling it because I'm, yeah. I don't think I am. Regex find one with this handle and this literal is going to call find many. I see, we're doing an early return because either the handle or the handle root are not valid. And I'm pretty sure this is setting the root to whatever the character should be. Root expects this character. Oh, wait, okay, I'm returning empty here. Returning handle. Though it still does an early return. Even though starting at the root, we're literally printing all of this stuff. Start here, go 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 here. Yeah. We have an entire list going on here. And we're returning the handle which has it as the root. And I'm passing the handle into this one. So how do we have an early return? Is there no handle? No. Is there no handle root? Probably not. My God. We had an inverted condition. That's what it was. Yo. Hold on. Hold on. Test passed. First try? I matched one character to another, okay? That's it. Literally a sequential list of characters to a sequential list of characters. Yep, I did that. It was complicated as hell. No, it wasn't. It's actually really easy because it is really easy to do, but of course, if you just want to do that, you just match two strings. If you want something more complex, then you want regular expressions. Alright, I'm not gonna keep this, but I am gonna keep. How do we make it a little bit more complicated? What's the first rule that I should introduce? Should I maybe try to introduce this one? I think that will give me... Alright. That will give me loops. And it's also technically not correct. The correct should be this one. But it doesn't... Well, to be fair. You're better off writing it like this, right? But the entire point is to test it like this. So, yeah. There we go. I'm going to use this one instead. Okay. If we're not supposed to ignore, we're then going to check if certain characters are being used. The first rule that we're introducing is plus. The 0 or more. That's what I was going with, that za. 0 or more is also going to be really easy to implement. But let's do one, figure out the logic for that one, and then move on to the next one. Okay. If next character, then the interesting thing is the previous node, success, will point to itself. To the previous node. Right? So we found one, and now we try to find the next one. And in this condition, we'll need to tell it to set this node, this next node next time, because here we're going to continue. This next node next time to the fail state instead of the success state. So I'm going to create an enum for it. I'm going to call it the regex stay append regex append success, or regex might not even be append, might be operation eventually, so that's why I'm making it into an enum. I feel like there's going to be more cases where this is going to be useful. Right, but regex stay append current append rule. We're going to go by default. You append to success. Whereas here, you tell it to append to fail instead. Here you switch on that. You break and you append to that one, to the previous node's success. You append the node, or to the previous node's fail, you append the node. And then after you're done appending that stuff, you're going to also set this back to its default, which is success. All right. So if I did it right, I can make this function recursive. It's probably going to make it a lot easier to visualize the graph. So we're going to do a void regex debug with a regex handle. That is going to have this. Unless we don't have a handle or we don't have a root. Actually, since this is a debug function, we're going to print no handle. And if no handle root, we're going to print no root. And in both of these cases, we're going to early return, but we're going to tell you why we're early returning. That way we debug. All right, so we're going to do this. We're going to take the current node, which is going to be root, and then we're going to do void regex debug node, which is going to take a regex node pointer, not nodex, node pointer, and if it has a success, well, no, first off, it tells us the, let's give it a depth. First, it's going to tell us the character that it expects. Then, if it has a success, it is going to try to debug that one. With a depth +1. And then if it has a failure, it is going to try to debug that one with a depth of +1. Four-letter words in both cases, for the sake of simplicity. And I'm going to steal something else from my compiler now, which is the indentation. This. And this. I feel like I should put this in a helper somewhere. I'm gonna do that actually, yeah. Utils. Indent.h. Put these. And indent.c. Put this. Including indent.h. So that's going to help me auto indent my stuff based on the depth that I pass it. It's just a simple macro for that. And I can just put that in as a string. Indent by depth. One of the parentheses didn't make it in for some reason. Whatever. And then, of course, need to include utils indent. I'm not recompiling the library, so there, now, yeah. Okay, and it broke now. Although that may make sense. May make sense. I'm not sure. Regex debug with the handle. So that's what I wanted to do. Hold on. Just run that. Too much noise happening. And also don't run this or this. Who's printing that? The debugger. Oh wait, I never called... whoops. I'm still running the recursive version of the function. Okay, so we expect this, 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 this. When L fails, O, this. And keep in mind those nodes are not repeating. That didn't work. That should have actually failed to print. That should have led to a stack overflow. Because L points to L, which points to L, which points to L, which points to L, until you run out of space. So we need to put a condition to check for that, but the fact that it's not happening means that that failed. I did something wrong. In this case, you want to print self. And in the other case, you want to debug the node. But yeah, that should be happening. On success of L, we should be trying to look for more L. The previous node should point to itself as its successor. And the current append rule should be failure. We should then continue to the next rule. No, not next char. It should be the previous node's literal character. Node L should repeat and find the next one on fail. So that is correct. It correctly identifies that the previous node, which is L, should be matched one or more times. And actually, come to think of it, 0 or more isn't truly accurate because 0 or more requires me to access the node before that one. Before the previous. So 2 back, not 1 back. So maybe I'd need to make this some kind of stack-based thing, probably, instead of just holding 1 manually. That would make sense. And then it would make it easier to have the nodes without having to allocate them. Well, you still allocate them, but like, you would allocate them in a continuous way. So, I literally knew that already. Why didn't I do it? Also, to respond to that message on YouTube, is everything still a stack? Nothing is a stack. I kind of ignored that entire thing for some reason. Ain't that great? Isn't that just fucking great? For fuck's sake. Oh well. Again, we're building the entire thing. It's whatever. I'm always modifying this. I see the problem now. Alright, let's see. Yes, I kinda did it wrong. The self should also print on an indent. plus 1. But why is that not indenting plus 1 properly? This one also. The indentation here is weird, but anyway. We match this character, then this one, then this one, then this one, then this one, then itself again, and so on and so forth until we get to the end. Until we get to a character that isn't itself. When we get to a character that isn't itself, we try to match this character. Then this character, then this character. Alright? So we should have conditions. And even though the indentation there is wrong, will this work? No. And I think I know why. No. Found this instead of the expected O. Okay, so yes, kind of what I thought. Yeah. Is there a way to just, like, restart the current loop without... Like, continue increases I by 1. Can I just go back to the beginning of the loop without starting off by 1? Because I'm doing this. It's kind of ugly. But the thing is, I'm consuming one more token than I should. Well, that's still happening. Wait, no, hold on. Yeah, okay. The thing is, I also need to do it here. Okay. There we go. That is interesting. It says test passed, but these don't match? What do these mean? Uh, that looks correct to me, but I don't think it should be. I mean, no. I think the prints are being weird. First off, because of the indentation here being lower instead of higher than it should be. And second, because of these not matching at any point, apparently. That makes no sense. But it works. It matches. So it's just a print error. Right? Like, yeah, there you have it. It's matching. Okay. Now, I'm not on a stack right now. Replace it with a while loop and increment it. Damn, I'm okay with just reducing I manually. I guess it's fine. Yeah, because it's just a while loop. That's just a for loop. But in one special condition, I don't increment it. I'm okay with just doing this. Anyway, um, this should all be based on a stack. Because what happens for this character? 0 or more. It means the last character, the previous node, needs to be matched 0 or more times. No. Hold on. I think... No, wait, hold on. I thought this was already acting like a 0 or more times, but this is literally... Oh, wait, hold on. Yep. Yep. Okay, no. The problem that I'm having is the opposite problem than I thought. The way that I implemented the plus is the way that you should implement the asterisk. It works as 0 or 1. Okay. Yep. Okay. It works as 0 or 1. So actually the reason that this one was failing was because it didn't have this at the end. If I add this at the end, it matches 0 or 1. So I'm actually going to do it properly. I implemented 0 or 1. I didn't implement 1 or more. No, 0 or more, I mean. 0 or more. It's for the challenge. There probably are libraries that handle this in C. Not the POSIX one, apparently. Not any reasonable way. But yeah. Yeah, so this is currently matching. Okay, which is correct. This should match. But the character should be this one, in which it shouldn't match. Now I should also write a lot more tests, right? But doesn't matter. I should also like automate this part. But okay, the way that it works right now is character L succeeds succeeds and goes to itself. Fails and goes to the next character, which is O. Right? So we come here expecting to find an L. We don't find it. We just move on to the next character. O. That is the implementation of 0 or more, not 1 or more. The way that L should work is we should have two nodes for L. One of them, which finds, fails, that's catastrophic failure, succeeds, then goes to this one. Alright, so this thing is okay, but not how it should work. I still don't need a stack, funnily enough. I still technically do not need a stack. If I just... I'm still gonna use a stack, so it makes no sense to keep doing it like this, but at this point I'm just committed. Anyway. Clone the previous node. All right. Now, the previous node on success is going to point to this new node. The new node on success is going to point to itself, and we're going to do failure. Found L instead of expected L. That's not right. Found L instead of expected L. How did that print even happen? If the literal and the string data... Oh. It's because I moved the I back. So here I want to use this variable. Here I also want to use this variable. That way I don't have that problem. Alright, found O instead of expected L. Alright, that makes more sense. So, see our issue? L on success goes to L, which on success goes to self. On fail goes to O? Again, I don't understand why the prints here get weird. You indent by depth, indent by depth, indent by depth plus 1. Oh, is it just like parentheses in this thing? Yeah. It's parentheses in this thing. Okay, so that makes it more readable. The fail state here is wrong. Because I forgot to change the previous node to the new node. Test fast. Alright, so let's see the whole thing. We match all these characters manually, then we match an L. If that L fails, we fail the entire thing, because it's one or more. If that L succeeds, we then try to match another L. And so long as this succeeds, we try to match another L. But if that ever fails, we continue matching as normal. Plus. There we have it. And the test passes. And if I make it into this, then the test fails because string 2 should not have matched. Now, I'm only using 2 strings to test. That is ridiculous. So, let's automate this a little bit. I'm making a regular expression parser. And yeah, because they kind of work with like graphs, I'm printing them in a very ugly way. I said I was gonna print graphs in my terminal, which to be fair wouldn't help here, but yeah. It would definitely help, but it doesn't really matter. Okay. These are a little bit hard to read, especially because they use tabs, but they work. So I'm good. I've used them in a lot of places. I'm using them in like my compiler. All right. a regex test is going to be made up of a literal and a bool should match. We are then going to have a list of them. Where we're going to have the first one that should match. This one that should not match. This one that should not match. This one that should not match. And finally, das empty string, which should not match. I do think empty string is not going to be a problem. I do remember them kind of making it into a whole thing, but it won't be a problem for us. Int I equals 0. I is smaller than number array tests. I plus plus. We're going to get our result from a slice literal of the tests I literal. And if the result dot found does not match the tests I should match, then wrong result I in test I expected. Expected I got I. So wrong result in test I. Expected tests should match. Got result found. Okay. Hello, Mike. With a 1. And if we get to this point, we're going to return a minus uno. And if we get to this point, we're going to return a 0. Wrong result in text 0. Expected 1 got 0. What just happened? What just happened? You were good. What the hell? You were good. Come on, man. We were good. Expected 1 got 0, yeah. But it doesn't look like it's failing. Like, at no point does it say that it found a character instead of another one and return an empty result. Ah, okay. I understand now why the print was wrong. It's still wrong. No, it isn't. Except this should be here. Alright, that makes more sense. Does it have 3 L's? This versus this, 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 this versus this. This fails. That's normal, yes. Then it gets here. I don't understand what else is happening. Also, why this broke when I refactored the tests? Not when I refactored That's annoying. That is very annoying. Like, little sanity check real quick. That works. What the hell? Oh, okay, hold on. I'm using slice literal here, which is supposed to be for hard-coded strings. Slice from literal. Test passed. Okay. Very interesting. Okay. I'm gonna do one last thing. Well, I don't know if it's gonna be the last thing. Um, it's moving the previous node hard-coded shit into a stack. Because I will need it to make any rules more complex than the ones I have right now. Although, another thing that I am able to do right now is this one. Where I'm going to add an optional 8th character. So this should match, but so should this. Why 8? Because it was the first key that I looked at. HTML, CSS, JavaScript, Fast API, MongoDB. That sounds good for a first year project, but shouldn't worry too much about what technologies you're using, more so just about what you're learning to do with them. At the end of the day, the technology that you're using is not the relevant part of it. What matters is what you do with it. Not even the projects that you build, just like how you use them, how you learn to use them. So, it's not about building a regular expression library. It's about learning string manipulation, pattern matching, all of that stuff. And you know what really fucking sucks? Is that now whenever I say it's not about this, it's about that, I feel like I sound like a fucking LLM. I'm starting to question my own humanity. I'm like, did I just AI generate that fucking that thing that I just said? Obviously not, but feels like normalizing that type of speech. I don't like that. We don't want to normalize these people. Anyway. All right. The thing about you is that this should be pretty easy to do. There isn't even a new node to be created. You actually work just like this one. Oh, no, okay, actually. The way that this is implemented is by adding a new append rule. Both. So whether we succeed or fail, this is where the switch kind of breaks, because switches aren't really made for this. Eesh, what was I trying to do there? Hold on. I'm gonna be even smarter about it. It's not much smarter, but a little bit smarter about it. I'm going to use a flag type of enum so that I'm still going to need to use an if statement if current append a rule, but now it's done like this. Without the switch, without the break. Actually saving characters. Does that matter? No. But still, isn't that cool? So now I can make it append failure and the success. And whenever I reset this, it goes back to success by default. Good. All right. Slice literal. Okay, so string. The programming language string, which I mean C, uses these kinds of strings, which are null terminated. So their memory is this with a 0 at the end to indicate empty byte. Then that's just the end of the string. This can be kind of annoying because most modern languages don't do strings like this anymore. Instead, they tell you explicitly, this is a string, it starts here, this is its size. So that's a string slice. And of course, because C automatically creates these strings as null terminated strings where you don't know the size, and I like to use slices, that way I calculate the size just one time, and then I already know it. Whenever I need to, if I need to iterate over the string 100 times in 100 different places, if I do it over a slice, I've already calculated the size just once. So it's better that way, as opposed to calculating the size every time or just continuing until you reach the end. So I convert them to slices wherever possible. And so I have this slice from literal, which just, pointer to the string, is just the string itself, and then calculates the length using strlen. But then I have this thing which is meant for hard-coded strings to turn them into slices. That way I can hard-code slices by just doing... You know what's really funny? There's 2 of them. I just saw that. There's 2 of these macros. Whatever. If I want to hard code a slice, I do it like this. But that only works with hard coded because internally it uses sizeof. And sizeof is weird as shit. Because for a hard coded string where you literally have these characters, it gives you the entire size including the null byte at the end. But for strings like these that it's actually getting from here, sizeof is going to give me the exact size of the string without the null byte. So the 10 characters that are part of it, not the 10 plus null byte. So it's different behavior depending on where the string comes from. So when you take the string from a property like this, you use slice from literal. When you hard code the string, you use slice literal. Slice lit, I mean. Or slice, apparently. There's also slice. Yeah, that's the reason. It was, because of the -1 in the macro, it was ignoring the last character of the string. So it wasn't matching properly. That's what was happening. Okay, did I add? Looks like I did. Looks like we can match it with an 8 or without an 8, and it works. But 2 8s, we expect you to fail. There we have it. All right. Now, that is the most basic rules that are part of regular expressions, right? Because regular expressions have Let's write a little syntax for regular expressions. What we have right now is we have this match one or more times, this match 0 or 1 times, same as say calling it an optional, this match 0 or more times. Currently only supports individual literal characters, ASCII characters actually. Let's make it like that. Yeah, so that looks weird. Why are you aligning it like that? Such weird indentation. Why is indentation so fucky? Look how wrong it is. Look how wrong it is. Anyway. Yeah, so it currently only supports individual literals, which means we can't do... Well, technically, we don't need more than literals to do the regular expression that I wanted to do, which... Do I still have it? Well, considering it was in a completely different repository that I closed, no. But the one that I wanted to match was exclamation point, that character, then anything that doesn't match the closing bracket, then the closing bracket, then do the exact same thing with parentheses. I'm doing this in comments, so it's not super easy to do. And also, all those brackets are going to need to be double escaped. Besides that, no. Everything inside of these brackets will need to be captured, and everything inside of these parentheses will need to be captured because I will need to access them. The first one is the content that I want to show. The second one, I will need to do some extra parsing because there's multiple possibilities. It's one of the possible values that I'm using to tag the content. Since again, all of this is for documentation parsing. So auto-summarizing documentation, essentially. So this is the regular expression that we want. Although with double escapes, it's gonna look more like this. So it's gonna need a few more things. It's gonna need capture groups, which don't really affect how the regular expression is parsed, but they do affect how the regular expression is shown once it is parsed. And because I want to get specific substrings. So that. Also, I need to do... I don't know what these are called, groups. Okay, so capture groups and groups are very similar. In the sense that... wait, I actually got this wrong. This is like 0 or more times. That's missing. Yeah, grouping things together. And also... alphabets. I'm gonna call it alphabets. I'm not sure if that's the correct name, but essentially just like these things, where I'm saying capture anything that isn't this character. But you can also say it as like capture any letter. You can do it like this, A through Z, or even A through Z, which means lowercase or uppercase, any letter. And then you can even do numbers, or you can do anything that doesn't match this group. So I don't know what that's called, but I'm going to call it alphabets. Although I do probably have the Wikipedia page open for regular expressions. And in the syntax section, a bracket expression. Alright, so I'm just going to call it alphabets because that's a better name. There's technically other things that I don't super need, such as these, minimum and maximum. Which really just requires me to count how many instances of a node appear. That's about it. And then it can get more complex than that, but I don't think I need to make it more complex than that. Alright, so I'm not going to bother with moving it to a stack-based structure unless I need it, because it turns out I haven't needed it so far. But again, the two things that I need is to be able to match an alphabet, so more than just a character. Although technically I can get away with just being like, match anything that isn't this character. Right, so inverting the condition. Not great. So we're gonna try to a weird position to sleep in. We're gonna try to do it properly. And also we are going to try to do capture groups. That's maybe when the stack-based design is gonna be more useful. So I'm gonna have to see. I'm gonna figure that out. Because of course there's gonna be like a little certain level of recursion. Since this is an entire group, and even this is an entire group, then yeah, stack-based is gonna be a lot easier. Where instead of keeping a pointer to the previous node, I'm just gonna keep its index and I'm gonna go look at it in the stack. That way, even if I added like, that node has like 10 nodes inside of it, and I'm now out of that node, and I'm in the next one, and I need to refer to the previous one, I need to go back 11 places. It's a lot easier for me to do that if I do a stack, probably. Either that, or I make this thing recursive somehow. I don't love that idea. But it could also work. There's not much of a point to it. Also, the helpful thing about the stack is that it's going to be a lot easier for me to navigate it. Because I'm guaranteed that it's always going to be continuous memory. Even though this pretty much guarantees me that it's continuous memory because I'm not using that much memory, you never know what's happening in between. What other allocations your program is doing in between the parsing. Although it is a single function in a single threaded system. You kind of know right now that there aren't any more allocations happening. But just in case. If I can guarantee that it's always going to be stack-based, then it makes more sense to make it stack-based. Alright, but I'm going to leave that for next time, which is probably going to be not Sunday, Friday. Probably going to be Friday, not tomorrow. Tomorrow, I want to build my build system in... Why did I want to say Z? I want to build it in Lisp. Right now it works okay. That's fine. But I have one big issue with it. It's that you need to compile the build system. You need to compile the compiler, essentially, for your program. Which it actually is able to recompile itself, but it isn't the best. And I do use a utility for it, which is redc, which automatically compiles it for you without it already needing to be compiled. but it's not great that I have to do that. And I find it much easier to have one that is script based. So I was considering doing that for a bit. And I think Lisp would be a great language to do that in. And then I actually wouldn't mind it if I was able to turn it into a makefile. Like, I was already considering doing that with this version of the thing. But essentially, in the same way that I'm turning it into this, which is then used by Clang to know how to compile the program, turn it into either a static compiler, like a bash script, or into a makefile, which would be better because makefiles automatically keep track of like progressive compilation. I don't know what that's called exactly, the exact name for it, but it means that it won't recompile unless it really needs to, whereas right now it always compiles. So I kind of want to make it into a standalone build system and also able to emit a makefile for compatibility, especially inside the operating system. I don't want to have to run Lisp because, like, if you want to use my regular expression library, then you also need to use my build system. Whatever. Especially when it's done with Lisp. Whatever. It's gonna be simple-ish. Enough to do. But since the OS is a much bigger project with much more visibility than any smaller library, if I include smaller libraries within it, then I want them to be able to be compiled with makefile. I don't want to maintain both my own build and a makefile, so I want to have one create the other. Try. I don't know. I'm gonna experiment with that a little bit tomorrow. So tomorrow's gonna be Lisp again. Tomorrow is going to be Lisp again. We're going to try to make a new build system. Also, the build system relies a lot on linked lists, which is literally what the list in Lisp stands for. So it just makes sense. And not the cutest thing to work with on C, to be honest. So yeah. Also want to write more Lisp. Also, I can do whatever I want. So yeah, tomorrow's gonna be a Lisp stream. Just not sure why I'm justifying the decision so much. I've been saying it for a while too. But yeah, I'm gonna go back to the regular expressions on Friday then. And hopefully, between tomorrow's Lisp build system stream and the rest of the week between tomorrow and Friday, I'm going to be able to have a build system that I can integrate into the OS. And I can compile this library and include it in the OS once it's ready. That can be Friday or next weekend, essentially. Alright, that's going to be the end for today. Also, next weekend I'm going to go back to my usual streaming time, the one that's on Twitch. But that doesn't really matter right now, since tomorrow I'm streaming at the same time as today, 8:30 p.m. Central European Time, and we're doing a build system, and I'll see you then.